everybody, and welcome to another Houdini tutorial. Before we get started, I wanted to say thank you for 1,000 subscribers. We hit that milestone last week, and I would have properly celebrated it, but I was in processes of moving apartments, and it was just one hectic time, so something else will be coming later down the line. But for today, we are going to be covering some beginner basics. So today we'll be covering some beginner nodes and some basic tools you can use in Houdini to create some starter simulations. The starter simulation we will be creating today is a mixture between modeling, collisions, and also particles, which is something also you guys requested a little bit more of. So let's get started. We'll also be covering a little bit of rendering, not too much. The first thing you'll do when you open up Houdini is your file. And under File, always save after you make any change in a .NET. And a .NET is a dynamics operator network in Houdini. These operator networks we'll cover a little bit later, but you'll understand how fast things can go wrong. So we'll save this as begin. I'll spell this wrong, but please spell it the way you want. So let's start up here. Up here are your lights, and you can see collision particles. We're not going to be using any of these. We might use this one a little bit later, but we're going to start with our lights. What are the most important lights to use in your sim? Well, I always start off with a distant light because it simulates the sun. And by simulating the sun, that basically gives you a lot of direct lighting onto your objects. So if I put a sphere in the scene, and you can click sphere up here, you'll see this box appear in your screen, and if you hit enter on your keyboard, it will automatically place a sphere at 0, 0. So you can see that your light's here, and if you click on your light, and you move it, the lighting will change. So that's your direct light or your sunlight, as you will. And you can place this anywhere in the scene and adjust it from there. The second most important light to use in your scene would be an environment light. This might happen, just ignore it. It's nothing too scary. You can close it. So you can see your environment light right here. By diving into it, you'll see the switch, a null, and an object merge. You can't evidently change them, but that's a concept we'll cover later on. So environment light is important because it allows you to bring in your environment maps, so your HDRIs. And this is important when you're rendering because if you're wanting to get your shadows and your lighting correct with whatever plate or background you're using, you'd probably want to use an environment map that matches your background. So let's say if you're creating sand and you want to put that in a desert and your background is a desert, you're going to want lighting that has that orange color of your desert and the lighting, the direct lighting of the desert itself. And maybe some shadows of the rocks around in the desert. And if you have an environment map of the desert, you can place it in here. So if we go over here to our little pointy sign, and we go down to Houdini Pick HDRI, you can see that Houdini already comes with 3 free HDRIs to use. I like using this one because it's a default area of your mountains. Now you may have noticed my screen shift a little bit, and that's because I hit space G on my keyboard. If I zoom somewhere in the scene and I click space G, it brings me back down to 0, 0. So it's a great way to recenter yourself in your environment in Houdini. Now if we go over to our network view, which is this, we can hit L and that will rearrange our nodes more neatly, which is also important to use. Now the other thing I'm going to do before I make any changes is I'm going to click this, and that's going to just turn off my lighting so it's not distracting while I work. So I'll dive into the sphere, recenter it, and suddenly we have these polygons. So now the easy part of our simulation is about to get started. I'm going to use one of the most beginner nodes you can possibly use in your sim to quickly generate results, and that would be Polywire. Now Polywire can be a little bit tricky, as you're about to find out, so it's always important to make changes to this node before you actually take this blue marker, which is your display renderer, and place it on your polywire. So click it here and you'll see why in a second. So you can see it's all jaggedy and everything. But if we go to the wire radius and we lower it to something like 4, or even lower, it's generated these perfect meshes, which is really nice. It's almost like a ball. We can also add divisions. And if you're modeling, this is pretty good in case you need to make any quick meshes or fences or anything like that. We can even choose to make sure the normals after editing our geometry are correct by laying down a normal node. So this will, and I'll show you in a second, these are the normals on your sphere. We go to a polywire, you'll notice they're a little bit different. So what this has done, it's reformatted the construct of the normals. So I think that's pretty good. We're going to go and add a null. Nulls are important. I've done a tutorial on nulls in the past and I can link it below. But basically these are good like landmarkers in your scene. Say this is where my geometry ends and this is where the simulation begins, or this is where the simulation ends and this is where I'm going to grab my simulation and bring it into another node. So they're very important. You can also store, if you go to the edit parameter interface, you can store different values into your nulls. So you can do integers, floats, etc. But that's more of a complicated process that we're not going to talk about today. And this, it's also useful in case you're seeing, if you go to this parameter window and you want to just lay your wire radius, and you don't really want to be diving through all your nodes, you can store them in the null through that little handy interface. But right now we're not going to do that. We're going to keep things simple. So we're going to go to our null and we're going to rename it OutGeometry, or OutGeo for short. So that's pretty useful. I'm also going to go up here and I'm going to add another null that says OutSphere. And now the fun thing begins. We're going to add down a popnet. And what a popnet is, it's a dotnet. So as we discussed very briefly before, a dotnet is a dynamic operating network. So this is where all the simulations get created and you can add dynamic forces onto your simulation. So just quickly and briefly, I'm going to show you what this kind of looks like. But before I do anything, I'm going to lower my timeline to 120 frames. And I'm also going to save before anything goes wrong. So if we go over here to our little timeline, you'll see this clock face. Turn it on because this is a real-time toggle and it allows you to play your simulation forward in real time. And those would be your particles on your sphere. And as you can see, nothing really happens. It just generates dots or points or particles, whatever you'd like to call them. So by going to our out sphere, we can do one thing that I think might help this be a little bit more dynamic. We're going to add another important node beginners need to know, which is called the scatter node, which adds points onto a sphere. And now this is a little bit different than .NET, as these points or particles are not dynamic. They just take the points. They just generate points from your geometry. So you can see the points here. If we go to our scatter, there's more of them, but it's generated across the surface of the geometry. But they don't move. So if we play this back, nothing happens. It's not dynamic. You can change these functions, and you can also turn off relax iterations to get a more non-uniform feel of the points. So if we go to our popnet, suddenly nothing happens. A little bit confusing, right? Well, if you go inside here, I'm going to delete this because I don't really need it for this tutorial. This is on scatter onto surfaces, and this is great if you're working with geometry, but now we're working with points. So you want to change this to points, or you can change it to all points. I don't really recommend that unless you're getting into some more complicated or dynamically different situations, but we'll get into that shortly. I'm going to use points, and if we go back here and we turn off our guide, suddenly our points are back and they're working again. So if we go to our birth, we can change the life expectancy of our particles. If we turn this down to 1 and we hover our mouse over it, how long the particles will live on in seconds. And this is important to know. So if we do that, they should all start dying off around the same time. So once per second. So remember, as soon as it hits 24 frames, the particles start to die. But they keep on generating. Now we can add some life variance, which means this will spread out, you know, randomize when the particles die. Doesn't really do much, but it's there. You'll see it more when we add forces, but that's important to know. And you can also change the birth rate or the amount of particles you have. So if we change this down to 100, you'll see less particles. So to add more variation into our simulation, I'm going to add something that I didn't know, well, I was aware of, but I didn't use for the longest time, and that's called the attribute noise. And what this does, it will generate color across your geometry. So if we animate this, you'll suddenly see it move, which is pretty cool. If we remap the noise, we can get some darker values. And this is really up to you of how you'd like to do it. You can change the periodic flow, we can change, basically these are like noise maps, but they're colorful. And they're based on point position, which is kind of cool. So that's moving away. We can go to our scatter. And our points really are now holding the color of our noise map, which is interesting. But there's one thing we can do to make it more interesting. We go to our scatter, we turn on density attribute, and turn this to CD. So the noise from the attribute noise is generating an attribute called CD, which is color. And by scattering the points on the color, we can suddenly have moving points. And with our PopNet generating points on top of our color, we can have a dynamic simulation built on those points. So now we add our forces. I'm going to use a pop one because that's the most easiest to understand. And if we add a 0.1 here, we'll see something happen. You can see it slowly start to move. Not too much. Do something like 0.5. You can see those points suddenly start to go, which is really cool. And here, you can't really see the velocity of those points, but if we dive out here, still can't see the velocity trails. Guess we'll have to cover that later on. Ah, there they are. They're just really tiny. So now that we've covered these being really tiny, we should probably click D on our keyboard and go to visualize. Well, not visualize geometry. Under particles, you can go to point size and you can adjust the size of your particles. Helps for visualizing. So we've got some moving, eclectic particles. Now let's go to our out geo. I think what we can do with this is create something a little bit complex and also cover collisions just a little bit. So if we click this and we go to collisions up here and we click static objects, we click this and we click enter, not delete, enter. You can see it suddenly starts to move. You can see those points suddenly start to go. Which is really cool. And here, you can't really see the velocity of those points, but if we Make sure geometry is selected. Let me go to our .NET. It's not there. Okay. So click this, jump out, select this, and click Static Object. That should work. And now you have our collision source set up. And if we dive inside our PopNet again, we'll hit L, and that will lay everything out for us. Now I'm going to save again before this gets a little bit complicated. And I'm going to show you what might happen. So everything looks kind of normal, and you don't see... That's actually pretty good for collision. I was expecting something to go wrong. Let's see what's going on with our collision object. So we click off Display Geometry, and we're going to go to Physical. No, we're going to go Collisions, and we're going to turn on Collision Radius. Ah, there we go. Something did go wrong. So you can see that this is not appearing. And that's weird, right? So that means it's picking up our collision geometry, but it's not generating the mesh. So I'm just going to play with this for a little bit and see what's going on. Ah. So you can see what's exactly what I thought was going to happen is now happening. So it sensed the sphere itself, but it's not sensing the divisions of the sphere that we have set up. So if we skim through this, see if anything works. Nothing really does. So if we go over here to our collision radius and see what's going on, could probably turn off this or this. Jump back inside. So we know it's something going on here. So I'm going to turn down the voxel size just a little bit, something like 0.4. Huh. Still not working. What can we do? Well, this is going to be an important lesson to learn because things will go wrong in collisions. So I'm going to not do that. I'm going to hit Y on my keyboard and the scissors will come up and separate the output here. We're going to use this because this is what I believe our collision object is grabbing. Let me just double check. Ah, no, it's grabbing the attribute create. So we're going to need those. I'm going to go to VBD from polygons. You can see it's already generated something of a mesh for us already. So if we go back in here, it's suddenly working. We can see it. It's an easy way to bypass stuff for collisions, and it works. And suddenly you don't need high-res collisions. So our collision object is there, and we have something happy. Now let's generate our particles and see what happens. And you might notice it being really slow. Why is this? Well, because we have this collision radius turned on, and it will always slow down your simulation that way, so be aware of that. But you might notice something interesting start to happen. We don't really get too many interactions with our collision object, and that's because our emitter object and our collision object are the same size. So it's not really interacting, rather it's being emitted from inside our collision object. So we need to change the shape of our emitter for this to work. So we go to OutSphere, and we have transform. We cover one of the most basic tools you can use in Houdini, which is transform, which allows you to literally transform anything in Houdini. So I'm going to make this a little bit smaller, and I'm going to go inside. I'm going to add a gravity node because I think that's going to be a little bit interesting. And we're going to click play, and suddenly you can see it interacting with something, right? What could it be? It's our collision object. So I'm going to lower our emitter object just a little bit, so it's sitting on the ground of our collision object. And one way you can do that to line it up, turn on this, click on this purple flag, and lower it or turn it, in this case, to wherever you want it to go. Cool. But I think we can have a little bit more fun with this, especially since it's sitting at 0, 0. We can add a pop force, or a pop axis force. And a pop axis force does something really cool, which you're about to see in a second. If we go to speed, lift speed, and suction speed, I'm going to also add more particles because this can be really cool. You can notice that the particles are now shifting through our objects a little bit differently than they would now that I'm adjusting the speed. Orbit them. By shifting the radius, you can get different results. And if we adjust our life expectancy to something like 2, not 22. So that was what it would look like with 22. And this is what it would look like with 2. Now it's going a little bit too fast. And we can get something cool looking. So this looks a little bit weird and wonky, but it's working. And now that we have our particles, we're going to do something a little bit different. We're going to save this, and we're going to go to our delete. And our delete tool can be a little bit confusing if you've never used it before. Basically, you can delete edges, points, primitives, but we want to delete points. So what this will do, it will delete anything you tell it to. In this case, I want to delete by range. So it's only going to delete particles within those range values. And if I go delete non-selected, deletes the other points. So we're going to create 2 of these. And this one's going to be delete selected. This one's going to be normal, this one's not. We're going to add a trail. And this will trail our particles, and the trail length, we'll add more. Can add some cool effects, but it can be very heavy, so be careful. A trail node can also, connect things as meshes, which can get pretty ugly, as polygons, and as velocity. So basically it'll add more velocity trails to your particles. But we don't want that because they already have a nice velocity trail going. We're going to go to an add, and we're going to go to polygons by group, and we're going to go by attribute and do at ID. So what ID is, it's now going to introduce us into a concept which you might not be aware of. It's in our geometry spreadsheet. So in our geometry spreadsheet, remember how we were talking about a color attribute just a little while back? Well, there's our color attribute, and you can see it changing over time. You can see our point position of our particles move across the screen, and the forces being applied. Now you will see the ID over here changing as well, and that's the attribute we are affecting. And each point has its own ID. So you can see these little things get emitted and trail around. I'm going to move this over here. Now, what we could do, we could bring back our polywire, but things might get a little bit heavy or a bit weird. You can see glitch out of existence, right? And you've probably never seen polywire look like a bunch of squares before. Looks really weird. So we're not going to do that, but I will admit this looks pretty cool. And if you turn off, go here and you switch this to like 100 and this back down to 0. My hypothesis is that these squares will probably stick around. Yeah, but it just still doesn't work, and it doesn't work for what we're doing. So we're going to turn our values back to what they were. And we're going to use something called attribute create. So attribute create, what it does, it allows you to create attributes. So we're going to create one called width. And we're going to go down to value and make it something really low. Like 1, 0. And if we go to our render view, we click this, we're not going to see anything because we're on frame 1. But if we go to frame 25, something will happen and appear and we'll see it. So let's take a look. Interesting. Now what could that be? I've never seen that error before, so I'm going to take a guess and say my mantra wants a camera probably. And I'm also going to change this. Actually, ray tracing works fine. Maybe turn this to something here, and if you hit left click on your key on your mouse and also control and you go to camera and you click down, it should create a camera where you are in your scene. And let's see what happens. Oh, and suddenly we have our points and they have our color values on them. That's great. But we also don't see our collision objects, and we also don't see our other particles. So what we're going to do, something a little bit sneaky. We're going to go here. We're going to hit merge. Oh yes, there's one thing that I'm going to do before anything else happens. I'm going to go to clean. That. And I'm going to go to attribute delete. An attribute delete is probably something really important that you should memorize. Not only is it important to have this node down after your simulation before you render, but it'll also save you a lot of time in rendering. By deleting attributes you don't need later on in your simulation, it allows you to render faster and also have a higher simulation time. So by deleting some point attributes, like color, because we're going to add that later, age, actually we're going to need age, or any of them generated by your PopNet, you can save a lot of time. Now, width we're going to need. So I noticed that I was doing that manually. There's other keyboard shortcuts that you can use to not do that manually and keep the ones you do and don't want, but I think right now doing it manually kind of shows you all of these attributes that you're generating from your PopNet, which is more important to memorize. So if we go to another useful node called color, this will help you generate color. So if we go over here, we have our lines. And now they don't have any color or values on them. But they're kind of glitching in and out of existence, which is kind of weird. Which is something to do with our lifespan. So I'm going to click out the life variance. Maybe we should add a time shift. Anyways, let's play that back, see what happens. Let me try something else. Okay, I'm going to try something. Of course. I'm going to try something a little bit sneaky. I'm going to add a attribute delete right here. And delete some attributes that might be causing this to happen. Okay, so I fixed it. Up here, I changed this to a 3 instead of a 2, and that seemed to work. So now, we're going to continue on in our simulation. We're going to go back to color. So if you scroll back down here, our color attributes are now gone. But what we can do is we can go to random. If we go to random, you can see some random color values are placed now on our points. And that's based on whatever value you decide to assign it to. Bounding box. If I turn off the velocity trails, you can see kind of looks like a rainbow, but it's based on point position. My favorite is ramp from attribute. And this here you can place, and I'll do it on the particles over here so you can see it better. We go to age. You can suddenly see, based on their age, the colors will fade from black to white. And we can basically change that from whatever value we would like. Going to also add a delete up here because you can kind of see our collision geometry being emitted. I'm going to delete anything isn't that. Cool. Suddenly we have our color, but we also can't see our lines. So we're going to turn on age. And we can see our points now. Yay! We can turn this from blue and pretty much pick any color that you like. See the points and particles being generated together on a collision surface. So you can flip this upside down, suddenly we get something kind of cool. Almost very nebula-like. And I'm going to create a new camera down here. So if I'm going to go to my render view, and I'm going to go to camera 2, and we're going to see what happens. Suddenly you can't really see anything, right? Looks a little bit weird. If we go down here, turn up the brightness, kind of only see our lines, which is really weird, right? But if we start clicking around, suddenly we see our points. Why is this happening? Well, we have geometry on this side and points on this side. And if you merge them together, only one thing is going to appear. So we're going to solve that issue later on. But first, I'm going to concentrate on our points because they look really wrong and they look really, really big. So before I do anything, I'm going to save. And I'm going to go back to our attribute randomize. We're using a lot of these because they're very useful. I'm going to put it before my color. And I'm going to change this to p-scale. And what p-scale does, it controls the size of your points. So by making these really, really small, and then rendering them, we can see something start to happen. But they're a bit too big still. Maybe still a little bit too big. I'm gonna go to 1. Suddenly they're a bit too bright as well. You can see that. That would be because we don't have a material yet. you may all also know they're moving, but they don't have any motion blur. Why? So I'm going to turn on motion blur just for this node, just so you can see that. Yes, this is important for every beginner, and this sometimes catches me too. You can have motion blur turned on here, and for all intents and purposes, I'm going to turn that off. And we're going to go to our render engine and allow motion blur, because if we don't have this turned on, the motion blur will not be turned on. Make sense? So, we have our spheres, we have our lines. What can we do? Well, I'm going to show you something interesting you can do when we get to the situation of only one thing will render. So we can add our useful nulls back down. We'll go particles, null, lines, and up here we have our out geos, so that should be good. I'm going to rename this to something like sim, and I'm going to hit L. Let's go to geo. We'll create 3 of these and copy paste them. Name this one particles. Geometry, so geo, and lines. And now what we can do is we can turn off our display flag on our sim. We can also get into materials once we bring in our chosen thing. So if we go to our object merge, go to specified object into this object, and I'm going to copy this because we're going to use it later. And we go to simulation, we go out particles. We're suddenly bringing in our particles into the object. I should have added down a cache node prior to creating this output node, but I'm going to do it here instead. Everyone has their own way of doing it. This is the way I do it. So, a file cache will save you that sim time. Just gonna name this particles, hit load from disk, go here, go to my desktop, go to geo. If you don't have a geo folder, Houdini will automatically create one for you. Don't panic about it. I already have one called particles up here. So I'm just going to create particles / basic dot $f dot bgeo. And bgeo is a file format native to Houdini. And then you save this to disk. And it shouldn't take too long. Cool. And that renders so much faster, right? Really cool. If we go to geo, we can paste down that object merge, go to out geo, there's our geo, go to lines, paste that down, grab our lines, then add a file cache. Now, this looks kind of boring, so we're going to make it interesting. We're going to go to our material palette, and we're going to choose whatever we want. I'm going to use copper, aluminum, and the metals for this because I like my metals. And I'm going to choose one of them for all of them. And I'm also going to go to my sampling and turn on velocity blur for the particles and the lines. Otherwise they will not show up in your render. So let's go to our render view and render out camera 2 and see what happens. Oh cool, look at that. Got particles, whoop, that we can't see. I believe copper was on our lines. And we can change the color here if we felt like it. We can even add a mist of color, which you can change here. Now this looks pretty boring. I'll admit that. It's just a sphere with particles coming out. So what can we do to make it more interesting? We can go to object here and go to our camera too. And we can do something that I like to fool around with called polar, which will move things around your scene. Click land shader. Cylindrical. And you can just bend pretty much anything in your scene. Push things away with focal length, you can bring them closer. It's a good way to create abstract stuff while faking your skill at the same time, which isn't too bad. You can play with the aluminum color as well. And we can even choose to add background images into our render here. So if we were to select this, you could add whatever you want in the background. But we're not going to do that. Now this looks a little bit boring, so one thing we could do is we could add a mountain. A mountain's a pretty cool way to fool around with your geometry. It also makes stuff explode, which is why you don't do it while you're rendering. But I can add some variations into your shapes. And we might actually want to go back into our simulation and add more particles, because I think 1,000 is pretty low. So we could go 10,000. Remember to save everything to disk. And then if we click re-render, we should see something. I might go down here, turn off my emission. I think it's really in your face too loud. We kind of have a mesh with particles. So we'll let that render out. Okay, so we're back. I'm not actually entirely too happy with this, so I'm going to jump out of my camera view. And I'm going to adjust our camera somewhere. I'm going to add another camera right here. So I can see the mesh a little bit. And I can render it. But I can just switch it to cam 3. So let's see what we do, or let's see what happens when we play with our shaders and stuff. One way you can move your camera around in Houdini is by clicking this lock, and it'll allow you to move into your camera. By placing this camera really close to the sphere, you can generate some interesting things. Suddenly we have a very bendy and warped sphere, which looks kind of cool. What happens if we move to lens shader? Get something like this. And I'll let that render so you can see how weird and wacky it is. And that's pretty much all the basic nodes you need to learn in Houdini. My name is Kate, and I hope you enjoyed this video. I will be recording a lot more this weekend, so I hope to see you in the next tutorial. See ya! Bye!